we had some issues in the lab because you try and compare two banks for equality, because the account number that you use to make new accounts is static. It's pretty much impossible to make two accounts with the same number, which is good. It's what you want, but it kind of stops our testing process. And when you're hit with these kind of problems, you do what I did, which is that you actually take the testing behavior into the class so you can fiddle around in the engine room. So if I go down here, this is Robert's test for equality, and it's fairly, well, I quite like it. Make a copy of the new account number. Make a new account. So make a new bank. Set the account number to 1. Make a new account. That account will have the account number 1, correct? Correct? Make another account, having previously set the new account number to 1 again. So now we've got A and B have both got the same account in them with the same number. So I actually had to do some fairly unpleasant cheating to get to the point where I could test the banks for equality, because I'd done all these careful things to make sure that account numbers are never duplicated. So there you are. The code, the fixed version of the code is up on SharePoint. The one thing that people did have the biggest problems with in the lab is the behavior that tests to see if two banks are the same. This guy here. I think everyone got the problem. We want to compare two banks to see if they are the same, but so what you do is you start off, you need a bank reference, and what you've got is an object reference. So you use this thing called casting, and so now compare to now refers to the bank I'm comparing. Is that okay with people? And so now I just do what we've been doing before. I go through a series of tests, and every time I test it, if it comes back they're the same, I keep going. If it comes back they're different, I give up. And the first thing I did was if bank name, where's it called? Bank name, there it is not equal to compared to dot bank name, then that means that our two banks are different, and I can return false because the name's different. The second test which I did for mine was I go if bank accounts, if the number of bank accounts is different, count is not equal to compared to dot bank accounts dot count, then that means we've got different numbers of accounts in the bank. Different. Okay, the last thing you do is the fiddly thing, because for this one I have to go through the entire bank and compare every account with every one in the other bank. Does that make sense? The analogy I used about 10 times on Thursday morning in the labs was, if I gave you two boxes full of accounts and said these two banks should be the same, then as a person you would pull an account out of the left hand box, look at the account number, find the corresponding account in the right hand box, put them side by side and check them. If they're the same, right, repeat that process, get another account from the left hand box, find the number, get the one out of the right hand box, compare them, and just keep on doing that. If you're stuck in this kind of situation, you can't figure out what it is you're supposed to do, try and map it on to physically what you would do if you're using paper and filing boxes and cabinets and stuff. And if you do that, then it starts to become simpler. So if we just drift a bit further up here, we'll start to find a method called save. Where are we? Here we go. No, hang on. This method here does something very similar. What it does is it spins through all the accounts in my bank and saves them. So I'll steal that code and I'll drop it in here. And so that's going to work through all the accounts in my collection. That's fine. So what I have to do now is go bank B equals compare to. Now it just turns out that I happen to have a method called find account, and I can get hold of the account number of the other bank. So get the account number of the other bank, go off and try and find the account that matches that. If has that given me an error? What's the problem, folks? What do I do? Oh, it's account, that's why. I'm an idiot. Oh, that's even worse. Okay, so find the other accounts. If the account can't be found, what does that mean about the banks? They are different. If B equals null, because null means I couldn't find it, return false. And now we go if B A dot equals B, we're good. So I'll put a not in front of there to reverse that. And again, now this is directly analogous to me actually comparing each file. If I complete all those tests and everything comes back the same, I return true. So if the name's different, don't like it. If the bank accounts count is different, if the numbers of accounts, don't like it, then you have to go through and have to compare every single account in turn. But the good news is, and this is a really important lesson from this lab, the bank doesn't actually do anything other than tell you these two accounts, hey, are you guys the same? I've devolved the testing behavior to see if two accounts are the same into the account class. That's how we do it. And the question I ask going forward from this is, if I change the composition of the account, if I add the overdraft value to the account, then that doesn't affect how the bank compares itself with other things, because this equals devolves the test into the account. So that will work as long as the account works. It doesn't care what's in there, it just gets a message back saying, hey, those are the same or those are different. Does that kind of make sense? Any questions on that? I mean, the nice thing about where you are now with the bank is that if you follow the labs through to the end, you have pretty much got a working bank system. So any kind of data store that you might want to make, you can now realize, because you know how to do the front end and the middle bit to do the actual transactions, and the back end to do the actual saving and restoring. So when you get your coursework, which will be coming out a week today, we will have a really solid starting point. And my strong advice, written in big red letters, is when you get the coursework, map it directly onto what the bank does for you, how the bank works. Because if you do that, then it's a fairly smooth transition for getting it all to go. Or just do the game, which is the other thing we can look at, and that's today's lecture actually, which is getting started with XNA. So let's do this now from beginning. Right, first question that no one knows the answer to is, what does XNA stand for? It's supposed to stand for XNA is not an acronym, which is a beautifully recursive definition, the kind of thing that smart-ass programmers come up with. So yeah, maybe it is XNA is not an acronym. I have no idea. It's a little bit long in the tooth now, but none the worse for that. It's been superseded by a platform called Monogame, of which a little bit more in a second or two. It's a framework for writing games. The thing about it is that if you know XNA, you can quite easily slide across lots of other game engines which are out there and figure out how because they do. Because the fundamental behaviors of a game are the same wherever you go, and they're realized extremely easily and nicely by XNA. It plugs into Visual Studio, and so we've been making console apps and WPF apps, and now we're going to make XNA games, and it's all the same, just different project types. And so when you, I'll show you in a minute, we'll make an XNA game that does nothing. That's quite a fun thing to do. There are XNA project types that just do that, and away we go from there. The latest version is version 4. It's been version 4 for a very long time, but that's okay. It works with Visual Studio 2015, and if you want to get a copy for your own use at home, go to msxna.codeplex.com, and there's a big zip file you can download. If you do the download, then you'll find there are 4 installers and a text file that says the order to run them in. Run each installer in turn, and then run the final one, which installs it in Visual Studio. One pro tip: don't have Visual Studio running when you install it. I mean, I'll just show you very quickly because it's easy enough to do. If I go on to, I open up a browser please. Okay. So press the start button, that'll work. Let's start to Edge, where you go. msxna.com. Codeplex. Is that right? Let's see. No. Okay. One of the things I'm really pleased about is the fact that we only have this blooming 29th of February rubbish once every 4 years, because the way today has gone, I'm waiting for the plague of locusts to turn up. So let's see how this is going to go now. Paste that in, hit enter. Oh look, there, no, that's not that. So yeah, there you go. So there are different versions you can download depending on which one you want. Hit the Downloads tab, please. When you're ready, I'm in no hurry, you'll find versions for all the versions of Visual Studio from 2015 down to 2012 and 2010. Pick the one that matches, there you go. That's the one I downloaded, XNA Refresh, that one there. There's the download. Unzip it and then just run the installers in sequence. If you've got 2012, then use that, or 13. That's interesting ordering. Anyway, 2010 and back you go. I have not had a problem installing this. Dutch's piece of wood. It works on my Windows 10 system. It's worked on my Windows 8.1 and 8 systems, and also my Windows 7 system, so it should be absolutely fine. It might want to install the .NET Framework 3.5. When you install it, that's fine, let it do its thing, and it all comes out in the wash. And just to get ahead of myself and build up a sense of excitement and whatnot, I'll go into here and I'll make us our first XNA project. Let's do this. So new project, what kind do you want? Well, I'd like a Windows game 4.0, please. You can make a Windows Phone game if you like, or you can try to, but bad things will happen. It will complain you haven't got the emulation toolchain on there. You can even, although it's hard to do now, make a version of an XNA game for an Xbox 360. But that's kind of been deprecated too. But there are ways you can get XNA stuff onto Xbox One, PlayStation 4, Android, Windows Phone, iOS, and I'll talk about those a bit later tomorrow when we talk about Monogame. So let's call it Windows Game 2. That's a good name. Let's make it a Windows Game 4.0. Hit OK, and it says you want to save. Yeah, I'll save stuff. Yeah, why not? And it will make us a brand new empty game, which I can even run. And when I do, I get a screen which is a lovely shade of cornflower blue. If you've ever wondered what cornflower blue looks like, that's cornflower blue. I have no idea why they went for that colour, but it's kind of pleasing. But that proves to me that XNA's kind of got it going on, and we're okay. I'll add some more things to this as we go through the lecture, but to get back to the plot, the install's pretty easy. Just go there, run the installers. It's not very large. You don't need a machine with fancy graphics. For the purposes of the coursework, you can do it on an Atom if you feel so declined. But the problem with an Atom is running Visual Studio on it, not running XNA. So to run on anything, i3, i5, whatever you like, it'll be fine. We're not doing any 3D, we're not hammering it, so it should work fine. It works fine on my Surface Pro, which has a built-in Intel graphics chip, and it's not particularly great. So it'll be fine. It's on the machines in the Fenner Computer Suite and in Robert Blackburn in the labs in our building. If you go into Studio and open up New Project, you'll find all those ones you've just seen sitting there smiling at you. And so it's all easy enough to use. I have shown you this bit already. Just go down there and select Windows Game 4.0 and away you go. The other types, yeah, I did actually have my games running on Xbox 360, which was quite sweet. That was a while back. And there used to be an indie store where you could sell them and do all kinds of bits and pieces as well. But for now, just use the Windows PC one and you'll be absolutely fine. If you do that, you get something we haven't seen before. This is a bit, well, it's how it works. There's two projects in my solution. One's called Windows Game 1 and one's called Windows Game 1 Content. That's because XNA is a fully loaded, proper game development platform. If you make a game, only a percentage of the effort goes into the engine. Tons of effort go into the textures, the sound effects, the maps, the scripts, all that kind of stuff, the character bitmaps, what you name it. And that's all content. And managing the content and getting it into a format where you can deploy it onto the target device is non-trivial. So what XNA does is it splits the code, which is the top project, from the content, which is the bottom project. And the idea is if I press deploy and I push it out to a Windows phone, it'll build one kind of assets. If I press deploy and hit Xbox 360, it might build a different type. And a third type for Windows PC. We don't care, it just works. But the content management side is kind of, I mean, the great thing for us is we can just drag bits of content into the folder and it will just, you can pick it up from there. It's so easy to do. But it does mean that we have this interesting split. We've got two projects in there, one for the content and one for the game itself. Now, it's a good thing we know about classes and objects because XNA uses these rather a lot. That's fine. And what it does is you make instances of objects and you work with them. The objects are all built into the framework. And the thing I like about XNA is it's a good way to learn about how classes work, because the XNA classes are extremely well designed and very well put together. It's a good way to learn how you would deploy something using a class-based infrastructure. And so it's great for that. Interesting things. If you dig down into the code, you'll find the game is actually run from a main method. Yay, go us. So we have using game 1 equals new game, make me a new game, please, run it. That's what happens when your game starts. There's something very similar happens when your Windows Presentation Foundation thing kicks off, but that's the code. I can actually show you it. Gosh, is this exciting or what? If I drop into here and I go into program.cs, then there it is, run the game. That's how the game gets started. And after that, the XNA framework gets control and makes everything happen. Okay, so we don't have to worry about how it starts up. We just have to fill in the gaps where the code actually needs our content, our behaviors, our stuff. And yeah, there you are, there's the blue screen. You can always spot rookie developers right in their first XNA game because all the rookie coders have got that as their background color. So if you see that, get that color out there, oh yeah, they haven't learned how to change the background color yet, oh dear. Let me show you. Actually, we can do that. Let's go into here and let's just do this. Let's go into here and do something. So in here it says color.cornflower blue. Right, okay, so let's go for color dot. Oh, I quite like T. What the heck is fire brick? Do they mean red? Let's see. Bam. That's fire brick, folks. So there you go. So not hard to do. XNA has color types built in, and it knows about things called graphics devices, apparently, which is interesting. So, yeah, if you want to make people think you're a proper advanced Windows game developer, just change the background color from cornflower blue. It'll impress them every time. Unless you actually need a sky, in which case I would use a different color anyway. But there you go. That's just me. So, This is important because this is how all games work. Every game you've ever played works like this. When the PlayStation 4 and Xbox One came out with their enormous processors and blah, I thought, maybe now we won't have loading screens. How naive. Every game I've ever played pretty much has a loading screen. You turn the thing on, it fires up, and it starts to load stuff. Once it's finished that, then the game can start. In fact, these days it's worse because there's a step 0, which is install 10 gigs of updates from the network when you start the game. In my experience, you get a brand new game, get it home, and you can play it tomorrow. When you left it overnight, pulling down all this. I think that's life. So, if you're actually using an XNA game, first thing that happens is we initialize everything. We go off, we create the game objects, we fetch the textures, we fetch the scripts, we fetch the models, everything gets pulled into the game. Once the game has been loaded, then we start on the draw and update cycle. The update cycle, read the game controllers, update the game state and the position of elements in the game, and then in parallel with that, we render the environment as fast as we can. And the idea is that these things tend to run in parallel because while it's okay to drop frames, it's not okay to drop updates. I used to play Need for Speed on Xbox One. No, Need for Speed on Xbox 360. Awesome game, being chased by the police. Really great fun. There was one bit where you'd be going down this hillside at enormous speed, and you go around the corner and a city appears on the horizon. You drive towards it. And what happens to the frame rate, folks? It goes through the floor. It goes the trigger vision. As you go around the corners, all this new stuff gets brought in, and the graphic engine goes mad. Now that's because the rendering engines had to slow down because it can't keep up. But the important thing is that your car still responds the way you like it to. It's still moving the controls, keeps the car on the road. What you don't want to do is break the speed of the update cycle, because if you do that, bullets start going through people and cars start just keeping turning when you told them not to. And so they separate these out because it's okay for this guy to slow down because the punter has to live with a bit of chugger vision. So what? If this guy slows down, the game becomes unplayable. And so in the XNA universe, they separate these behaviors out. But within XNA, they have a convention that update is called 60 times a second, and draw is called as fast as we can. Does that make sense? Every game works like this. Every game splits off the rendering side from the engine side because, like I said, you cannot tolerate the fact that your responsiveness has gone down, because you pull the trigger and the bullet won't come out for half a second, and by then the other guy shot you. And lag is extremely frustrating, and it makes games unplayable real quick. So we have these two behaviors going flat out, and this is how all games work. If you look inside an XNA class, which I'll do, you'll find there are 3 methods that I'm really interested in: low content, update, and draw. And when you start the program up, they're pretty much empty because there's nothing, we haven't added much to our game yet. Okay, so the name of the game, as far as we're concerned, coding wise, is we populate these things. But these map onto my 1, 2, and then these 2 things here. So that's my low content that brings the content in. This guy does the update behavior, and this guy does the draw behavior. I'm making a game, it looks like, called Pong Game at the very top there, and it extends the class Microsoft XNA.framework.game. Now we'll talk about what that means in a week's time. But for now, what I want you to understand is that when you make the game, you fill in these 3 methods. That's how you do it. A little bit of C#. Partial means, I quite like that. No, it doesn't. It's not even funny. Partial means there are other source files that contain code for this class. We've seen it when we made XAML apps. The main window class was a partial file. There's other bits of the main window class in other files on the system. Protected means this is visible in this class and any children, which again we'll cover next week. And using means if you leave this block, I don't need this thing anymore. Now, I'll just go back and underpin what that means by looking at this line here. You've not seen using before. Using is a way of giving the garbage man heavy hints, in that normally the garbage man has to go off and try and figure out if a thing's able to be deleted or not. You put it in a block marked using, and you're basically saying when this block finishes, this guy has gone. I have no other part of the program relies on this. It's perfectly okay to kill it the instant I let go. Now, it's a bit of a waste of time really, because when this thing ends, the whole program finishes. But I think they were just showing off and going, hey, I know what using means, and putting it in. But using is a way you can say, I'm going to use this thing, and when I've finished with it, it's gone. Remove it. I don't care. Garbage collect it. There's no reason for it to be there anymore. And it's a way of hinting to the garbage man that yes, you can dump this. Okay, so if we look in the low content method, we will see this. We will see it makes a sprite batch and it puts in a to-do. Now you've seen to-dos in labs and you thought I'd invented them, but no, it seems like I stole it from XNA, which is fine. We have to load our content here, and so we go off and fetch all the elements that make our game interesting. Load content is called once when the game starts, and that's its job. We don't start calling update and draw until load content is finished. That's how we enforce the sequencing, okay? And you can bring in what you like. There's a whole bunch of different content managers, and you can bring those in and just use them. Images, sound effects, 3D object meshes, scripts, videos. I even wrote a content importer for a dictionary for a word game that I was working on. And the idea is that, yep, we've got a rather nice content management system which is built into 2008 and other years. That's my ball image. It's not particularly wonderful, but let's go see if I can find something which is a bit like that. So if I go into, if I just drift out of here, go into Visual Studio, where is it? Oh, it's there, good. And then if I go into, I quite like this because it's kind of easy. So I now go into week 27, getting started. Here we go. So assets. These are all the assets I'm going to be using in the labs. You can, I'm sure, make better ones than these. They are all PNG files. Robert loves PNG files. Why? Yeah? Transparency, absolutely. PNG files, you can make bits of your image transparent. In fact, the ball that I've done for you is really nice because it's actually transparent. You can see things as it rolls over them, which is really quite sweet. If you use JPEG or GIF, then it's much harder, particularly with JPEG. With GIF, you have to basically say this color, normally bright purple, is transparent, and XNA lets you do that, but it's a bit of a faff. If you use PNG files, then it all just comes out in the wash, and bits that are transparent. I mean, the reason why my white dot doesn't look like much is because it's transparent and it's showing the white background behind it, which is not particularly impressive. Do you people know about Paint.net? Okay, if you've done games and whatnot before, then you might have heard of Paint.net. It's a really good free image editing program that supports layers and transparency and PNG files and all sorts. It's completely free. If you search for Paint.net, you can download it for nothing. Have you heard of the GIMP? Yeah, GIMP's the other one. GIMP is also free. GIMP is awesome, but my God, it's hard to use. It's really powerful, but yeah, there's two things. If you're going to learn GIMP and Blender, then you are a giant among developers, because both those are stinkers. And they're both free, which is not so Blender's great for 3D rendering. If you want to make some monsters and whatnot in 3D, use Blender for that. Blender's quite cute for that, but GIMP's good for 2D, and so is Paint.net. So, I carefully made myself a white dot. There it is. So how on earth do I add this to my game? Well, I grab hold of my white dot, I drag him into the content, bang, and there he is, white dot.png, and that's it. I've now added the white dot to my game. Isn't that sweet? I like it. Now, you can do that with as many images as you like, of any size that you like, up to about, I think it's about 2K. Anything above about 2K in direction tends to cause XNA to get a bit upset, but that's way too big these days anyway. So you put that in, and when you drag it into the folder and drop it, into Solution Explorer, it actually makes a file with that name. There he is. And he's sitting in my content, waiting for me to do something. Am I putting it in the right place? It's in the wrong place, isn't it? Yeah, idiot. I'll drag it across into there. That's better, so now he's in there. That's much more sensible. Now, he has a bunch of properties and stuff, but we don't care about those. Just remember the name, which is white dot, and we'll be absolutely fine. So, what else I had to say? Yeah, right, fine. So we've got the white dot in our content. It's all good to go. Now, the way that XNA works is that it basically says that in the context of 2D games, I talk about texture 2D as being the objects I'm moving around the screen. There is also a texture 3D, and XNA is perfectly happy to make 3D games if you've got the brain power to do it. Robert, that's me, does not write 3D games because his life is too short. Okay? I've got a lot of mileage out of writing stupid 2D games, and that's where we're going to go. We're going to go for 3D, then absolutely. But if you're mad keen on 3D, I would suggest learning Unity because that's much easier to use in that context. XNA is a little bit hardcore in that respect, but for 2D stuff, it's brilliant. It's lovely. So we need a texture to hold the ball during the game. So let's follow the rules. Let's go back in here and go diddly diddly. So I'm going to go into my Firebrick screen. That lovely. And I'm going to go up here, and I'll declare myself a variable texture 2D, and I'll call it ball texture or just ball. What is it? Ball texture. Okay, fine. Oh, go away. That's not helpful. Right, ball texture. So that's my texture. What Robert does is he goes something like, these are all my game objects. This is the stuff that my game contains. This is my game world, if you like. And at the moment it just contains one thing, which is a ball, which is fine. So, yeah, this will live inside the game class, and the draw method, the update method, can both use this to draw things on the screen. So that's, put that in. We're okay so far? We're happy? Yeah, wonderful, good, right, fine. So, now I do the bit that loads it. I use the content pipeline, which is the mechanism which fetches the thing and puts it in my game. So in load content, I actually fetch my texture and slap it in image, sorry, and put it in the text. So I go into load content. Where are you, my friend? Here you are. So I'll get rid of that to do because I'm doing it now. Look at me. Right. So now, ball. Oh, get it lined up. Okay. Ball texture dot that equals content dot load. Now, we've done generics before. Generics, we saw them in the context of lists and dictionaries and stuff, and we say things like, I'll tell you what type it is, and then you look after it for me. So you tell it's a list of accounts or a list of whatever, and the list looks after it. This is the other way around. This is load content saying, please fetch me a thing of this type. And it will do that, and I have to just put the name of the thing with a capital WH, white dot. So go off and get me a white dot and put it in the texture. If I run this program, you will be amazed. There you go, a red screen and nothing else. Woo-hoo, fantastic. But it must have worked, otherwise I'd have seen an error. So we're all good so far, let's keep going. So that gives us our way to get content in. So for every object in the game, you will have a texture, and you'll load it from the content like you've just seen me. So you just drag the asset into the content project, remember its name, you then say, okay, go off and get me one. I don't have to tell you what file type it is, because the texture 2D load method will go, I'm looking for JPEGs, PNGs, GIFs, and I think it'll probably do TIFF files. I'm not sure it'll do TIFF or not, but it'll do the other three. So go off and get those and you'll be fine. And that's the loading. Wonderful. You've seen that code and been mildly amazed. Now, we have to draw it. Fine. At the moment, that's the draw method that you get by default, although ours is now Firebrick red, or whatever it's called, rather than blue, but that's fine. Draw is called repeatedly. If I run my program, run this up, diddly-dee, there it is. It doesn't look like it's doing much, but I'll just slide that out of the way. I'll drop down here and I'll go and find the draw method and put a breakpoint there. Bang, we hit it. Run it again. Bang, hit it again, and again, and again, and again. This thing's called at least 60 Hertz. And all it's doing every time is clearing the screen to fire brick red. So it's not doing anything that you can see except for the fact that it is. One of the things that surprised me about games when I began writing them is that you'd think that when your game updates, it just moves everything on the screen a little bit to reflect the changes in the game world. It doesn't. It redraws the entire thing from scratch every time. So XNA has a rip it up and start again approach, which basically means that the first thing it does in the draw method is clear the screen. Bang, and it goes away. So it's interesting that it's not just tweaking the position of the things in the game as you're playing it, it is redrawing the whole damn thing from scratch every time. Turns out it's easier to do that than it is to figure out what the changes mean to the actual stuff on the screen. So we have to live with the fact that every time the clock goes tick, we redraw the whole thing from scratch. But that's fine, it's just how games are. So, back here, it's called repeatedly. At the moment, it's doing nothing. Now, if you know a bit about how games work, you'll know that lots of devices have got a thing called a GPU, which stands for Graphical Processing Unit. This thing called a GPU, it's a fairly dodgy one, it's only the Intel built in, but if you buy a really expensive PC with a very high cost graphics card in there, that's your GPU. And it sits in the system bus and it talks to the main CPU, the Central Processing Unit, and what happens is that the CPU sends commands to the GPU to tell it what to draw. So at the start of the game, all the textures get pulled out of the game and pushed into the GPU, and then we send the GPU commands to render those textures in certain places on the screen. That's how it works, okay? Snag is that assembling a message to go to the GPU it takes a while. Not long, but you don't want to be doing it for every single object that you draw, because that means that you'd be it's like sending a loaf of bread by posting each slice of bread individually. You wouldn't tend to do that unless you were trying to freak somebody out, which would work. You'd take the whole loaf of bread and put it in a box and post the whole lot across. That's what you do. That's what XNA does. So XNA says, I'll give you a signal that says, this is my rendering behavior, and then when I finish my rendering, I'll call a method that says, I've finished now, those are all the commands to go to the GPU, please send them, bang. And it just does it like that. So the idea here is that we have to batch up our drawing commands, and Spritebatch is a tool which does that for us. It's an object which is part of XNA, you get one free with the game, and Spritebatch's job is to basically batch up the drawing commands in a chunk of stuff which can then be pushed to the GPU in one transaction. Spritebatch does other things as well. If you send the same texture on 10 different sprites, Spritebatch will go, oh, I'll send that once, and just refer the thing to the other one, because that's a good use for references. And it will actually do some quite funky things to keep things going. But as far as we're concerned, we just have to call spritebatch.begin, which means now I'm doing some rendering, and then spritebatch.end when I've finished. So if you don't top and tail your drawing code with those two method calls, it ain't going to work. Okay? So we put those lines of code in, and between those two we put the code that actually draws the things that we want to put on the screen. Does that make sense? I think I quite like that, so that's good. Okay? So this is what I do. Spritebatch provides a method called draw, and with draw I can say what I want to draw and where I want to put it. And I'll just drop out and steal that code because I can. It might even work. Let's see. So I'll grab that guy and I'll copy it, and I'll go back into my game and I'll go here and I'll do that, and it seems to work. What am I missing? I haven't done my begin. Spritebatch.begin, and then when I've finished I have to do my end. End. Not equals, that would be bad. Okay, that's it. So I've told the Spritebatch. Spritebatch needs to know three things: the texture I'm drawing, where to put it, and the color of light to shine on it. which is awesome. I love this feature. So run the program now. And we should see a white ball on the screen. Yay, isn't that good? And because it's transparent, the red showing through on the edges, that's a rectangle, but because the ball is using transparency, the red background shows around the edges, which is nice. I mean, I quite like doing this. So now if I want to, I could shine a yellow light on here, and I could make my ball turn yellow. So there you go. There you go, now it's yellow. It's quite good. You can teach colour theory. If you shine red light on a green thing, how does it look? It looks black. If you do that with this, it does the same thing. So if you light up your your green sprite with a red light, it turns black, which I think is quite cool. I've used this in games. If you want to show your engines heating up, you want to show them getting redder and redder as the temperature increases, draw them in grayscale, and then set the colour of the light on them. So as they get hotter, you can make it go redder and redder and redder. And same thing for cooling down. So it's a lovely trick, one line of code. In terms of what we're looking at, these other two numbers, these guys here are the position, 0, 0 is top left-hand corner, and these guys here are the width and the height of the rectangle. So if I go in here and put 100, 100, what will happen to the ball? Well, let's have a look. It'll move down the screen 100 pixels and across the screen 100 pixels. The things to note about positioning, the top left-hand corner is 0, 0. So unlike bits of graph paper where you put 0, 0 in the bottom left-hand corner, when you're doing positioning in XNA, it's top left-hand corner. And as Y increases, it goes down the screen, which is annoying, but it's how it works. It's the same with WPF, exactly the same. So there's nothing to worry about too much. And so you can move things around the screen by changing the draw positions. The width thing, well, we can have fun with that. I could make this guy here 500 for giggles. Run the program again. Now we're going to see a ball which is kind of squashed. Yep, there you go. XNA is quite happy to scale that. Isn't the problem. It will do a little bit of interpolation. So it might look a little bit dodgy around the edges, but it's usually okay. If it's moving fast, it's absolutely fine. So you don't have to scale things yourself. You can drop them in the game and then make them the size that you would like to use. In fact, if I go back to my slide deck, I think that's what happens next. Let's go have a look. Where are we? Did I stop it? Oh, I stopped it, didn't I? Yeah. Let's go resume them. So, we can draw stuff, we can put colours on it. This is kind of sweet. The rectangle structure is a structure. It has 1, 2, 3, 4 things in it. The colours are white, shouldn't really be there. But this guy here is how we express whereabouts on the screen we want our sprites to get drawn. Okay? And we can move our ball by changing the content of the rectangle to reflect where we want the ball to be. And it's interesting, and if you think about it, there's a challenge for the evening. Spend some time pondering why rectangle is a structure and not a class. Why isn't it a class? We know there's these two different flavours, so why isn't rectangle a class? Piece of cheese to the person that gives me the best answer to that via email before the next lecture. Why isn't rectangle a class? Why is it a structure? So give some thought to that, because if you know that, you'll actually have a good understanding of why we have. In fact, ask me next lecture and I'll tell you all, but I might give some cheese out as well. So we can fiddle around with the size. We can make it fat and whatever. We can make it different positions on the screen, and that's all fine and dandy. Now, the way my program presently works, it actually positions the ball in the draw method, which is very bad form. So what I should do is something like this. Back to the game. I'll take this guy out of here completely, just for now. and I'll go up here and I'll make myself a rectangle, and because I'm big on names, I'll call it ball rectangle, and then down here in the load content I'll just make ball rectangle equal to the rectangle I've just made. So I've taken it out of there, and we'll make the, I don't know, we can make whatever size we like. We can make it ball texture.width so it's right shape again. So let's do that. Texture.width. Okay, so get the width and the height. So now we've got a thing called ball rectangle, and I can now drift back to draw, and I can pop this in here like that, and then just tidy up a bit. So I haven't actually changed the program much, really, because it's still yellow, it's still on the screen at 100, 100, and all's well with the world. But I now have something I can fiddle with in my game. So ball rectangle is now a member of the game class, and I can fiddle with the elements in it. Now, this is where update comes in, because update is where you update things in your game. So inside here, which is presently empty, I could do something like this. Ball rectangle.x equals ball rectangle.x plus 1. Well, hey, okay, run that, what's going to happen? Whee! Cute, eh? That's how games work, folks. You change the properties on the game objects, and they just drift off the screen and head off the computer. It's now going down here somewhere. As you've spotted, XNA is quite happy to draw things off the screen. That's going to keep on travelling until whenever. We would have to put some code in to make it bounce, of which a lot more tomorrow. But the thing I want you to take away, and it's a good time to stop, is that the whole basis of XNA is you have game objects which you manage by your program that represent things on the screen, and it all happens 60 times a second. Does anyone have any questions on that? Okay, I'll see you all tomorrow at the usual time, and then the follow-on lecture at the same time but in Allen. Thank you.